Have you ever felt the ground tremble beneath your feet and wondered what caused it? Earthquakes are sudden, powerful, and often frightening, but they're also a window into the immense forces shaping our planet from deep within.
To understand earthquakes, we need to look beneath the surface. Earth is made up of several layers: a solid inner core, a molten outer core, a viscous mantle, and a brittle outer shell known as the lithosphere. The lithosphere isn't one solid piece. It's broken into huge, puzzle-like segments called tectonic plates. These plates float on the semi-fluid layer of the upper mantle, known as the asthenosphere. Driven by the heat of Earth's interior, these plates are constantly in motion, albeit slowly, just a few centimeters per year. Where tectonic plates meet, enormous stress accumulates. These boundaries come in three main types: convergent boundaries, where plates collide; divergent boundaries, where they move apart; transform boundaries, where they slide past each other horizontally. These boundaries are the stage where most of the world's earthquakes occur. Over time, as plates press against, pull from, or grind alongside one another, stress builds up. Rocks resist this movement until the force overcomes their strength. Then, they break suddenly, releasing stored energy in the form of seismic waves. That's an earthquake. Earthquakes often happen along faults, which are fractures in Earth's crust. The most famous is the San Andreas Fault in California, a massive transform fault. The point inside the Earth where the fault begins to rupture is called the focus, while the point directly above it on the surface is the epicenter. Seismic waves radiate outward from the focus, shaking the ground as they travel. There are several types of seismic waves. P waves, or primary, are the fastest and arrive first. S waves, secondary, follow and cause more ground motion. Surface waves travel along Earth's surface and tend to cause the most visible damage. The strength of an earthquake is measured by its magnitude, a number that tells us how much energy was released. Scientists often use the moment magnitude scale, which is more accurate for large events than the older Richter scale. The depth of the quake also matters. Shallow earthquakes, those less than 70 kilometers deep, are usually more damaging than deep ones, even if they have a similar magnitude. That's because seismic energy has less material to travel through before reaching the surface. Earthquakes aren't randomly scattered. They mostly occur along tectonic plate boundaries. One of the most seismically active regions in the world is the Ring of Fire, a horseshoe-shaped belt surrounding the Pacific Ocean. It includes countries like Japan, Chile, Indonesia, and the western US, all frequently affected by earthquakes and volcanic eruptions. However, earthquakes can also occur intraplate, meaning within the interior of tectonic plates. These are often caused by old faults being reactivated under pressure, such as those responsible for the 1811-1812 New Madrid earthquakes in the central US. Surprisingly, not all earthquakes are natural. Humans can trigger earthquakes too. This is called induced seismicity, and it's been linked to activities like mining operations, filling large reservoirs behind dams, hydraulic fracking for oil and gas, deep fluid injection into the ground. These activities can alter underground pressure and trigger slips along pre-existing faults. Seismologists use tools called seismographs to record ground motion. By analyzing seismic wave patterns, they can determine the earthquake's location, depth, magnitude, and fault type. Networks of seismographs around the world help scientists detect and analyze quakes in real time. Although we can't predict earthquakes yet, scientists are developing early warning systems. In some countries like Japan, people can receive alerts seconds before shaking begins, giving them just enough time to take cover. Earthquakes remind us that Earth is a dynamic planet, constantly reshaping itself. They can be devastating, but they also play a crucial role in geological processes, forming mountains, recycling crust, and altering landscapes over time. By understanding the science behind them, we not only reduce risk and save lives, but also gain a deeper appreciation for the living, moving Earth beneath our feet.